Hi, I'm Alex, and today we will be addressing the topics of solving a system of inequalities, solving a system of equalities, and factoring an expression. I might be going rather fast in order to keep pace, and because you are paying by the hour. But if you'd like me to slow down a bit so as to see things thoroughly, please ask me. Now I will share the screen. And well, let us go to the first topic, solving a system of inequalities. Suppose that we'd like to solve this, 2x plus 4y is greater than or equal to 8. And y is smaller or equal than 3/4 of x. We shall begin with the first inequality. And the first, well, we will write it down here again, 2x plus 4y is greater than or equal to 8. So the first thing to do would be to get rid of this, but because we want to leave alone the y on one side of the inequality. So in order to get rid of the 2x, we will subtract 2x from both sides of the equation. And that would seem as taking this to the other side and changing the sign to a minus. So we would get 4y is greater or equal to minus 2x plus 8. And the next thing would be to get rid of this 4 that is multiplying the y. So we would divide both sides of the inequality by 4, and that would be as taking this 4 to the denominator here. Finally, we will get y is greater or equal to, here we have 2 divided by 4, which is 1/2 of x plus, and then we've got 8 divided by 4, which is 2. And that would be solving the first equation with respect to y. And this we could immediately draw in the xy plane so we would have here the x-axis and here is the y-axis, and we can check that this number 2, we call it the value at the origin. It means that whenever we have a 0 here, we are at the origin, 0x, this term vanishes and we are left with the 2. So y would become 2 when we are at the origin. So we would mark it counting 2, and this would be y at the origin for that inequality. And this here is the slope. So it is a slope of the line. So how do we deal with this? Well, when we move one step to the x in the positive direction, then we go down because of the minus 1/2. So we would go down, this would be a 1 complete, so we go half here. This other spot corresponds to the line that we are dealing with. So the next step would be to get these two together with the line. it is a solid line because it says equal to, greater than or equal to. It would be a dashed line if it was only equal, only greater than, not equal. So look at this. Y is greater than or equal to this. This is the line that we just drew. So this line has the equation y equal to minus 1/2 of x plus 2. This is the red line that we just drew. And because y has to be greater, it is above the line. So any spot above this line would correspond to the inequality that we are dealing with here. And next, we will check the second inequality. Here, y is already alone by itself. So how do we draw it? First, let us check the value at the origin, like this one. Well, in this case, it is a 0. This corresponds to plus 0. So the coordinate at the origin when x is equal to 0 is 0, so it could be here. This corresponds to the line of this inequality. And then the slope is 3 divided by 4. So we move 1 in the x positive direction, and then we go up 3/4. That would be 0.75. So this is 1, and we move, this would be half here, this would be 1 in the middle there. That spot corresponds, well, let's draw it again. It will be there. Because we move one step to the right of the x positive axis, and then 3/4, 0.75 upwards. And now we get these two together. There it goes. That would be it. So this would be y equals 3/4 of x. But because y has to be less or equal than this, it has to be beneath this line. It's going to be below the line, right? So now we match the two lines together and see what is the result of this. It will be anything between both lines. So any pair xy that is between these two lines would be a solution to this system of inequalities. Well, now we will get to the other topic that we wanted to address today, which is solving a system of equalities. Let's do this. Minus 12x plus 9y equals to 7, 3x minus 4y is equal to 2. This will be a system of equalities that we want to solve, that is, to find out x and y. Now, there are several methods to handle this. And one would be adding and subtracting, it is called. We can check there is a 12 here and there is a 3 in the other one. So if I multiplied the second equation by 4, I multiply by 4 this side of the equation and also this side of the equation by 4, then I would get 12x minus 16y equals to 8. Let's put this other one again here, minus 12x plus 9y equals 7. So if we add together both sides, the x term would vanish, they would cancel, and we would be left with minus 7y equals 215. So now we take this to the denominator of the other side, and y will be minus 15, 7. And now that we know uh, what is y, we could replace this y in any of the equations in order to solve for the x. For instance, we could do it in the first equation. So we would say minus 12x plus 9, and now we will replace y with the value that we have already found. Now we'd like to leave the x on one side. So this here we multiply it and then we take it to the other side. And this minus 12, we can get it to the denominator of the other side. So x could be minus 184 divided by 12 and 7. Here we could simplify. And that will be the solution. So x will be minus 46 and 21. There is an advantage here regarding that we could check whether our result was correct or not just by replacing the values that we found in the equation. For instance, if I replace y with this, I will leave this for yourself, and I replace the x here, this solution can be checked. That is an advantage of the systems of equalities, that they can be checked. They have to be linearly independent in order to give a solution. That means there also has to be a same number of equations with the coordinates. Otherwise, it will not be able to solve. And now we will get to the last issue that we were addressing today. And that is factoring. So, for example, we've got this expression 8u squared minus 17u minus 21. In order to factor this, we have to find the roots. Roots are something that when we replace them in the equation, it will cancel. So because we are talking with the second grade equation, there will be two roots here. We could call them R1, root 1, and root 2. So once we factor this equation, we will get to a solution like this: u minus R1 times u minus R2. That will be the general solution of the factorized equation. So let's find the roots first. And how do we do that? Well, we equate this to 0. Look, we would take the 8 out. 8. And this we equate to 0. And now we would complete squares on this term. We know that the second order equation is of the form a plus b squared. This is a squared plus 2ab plus b squared. So we'd like to take this into this form in order to find the roots easily. What we can see here is that this a squared, we've already got it here. So a would be u. And here this 2ab would correspond to this term. So we would say 2ab equals, remember that a was u, 2ub is equal to minus 17 by 8u. So b, in order to get b from this equation, we have to send this to the denominator on the other side. So b would be equal to minus 17 by 8 times 2u, and we got u here. So this could be simplified. And then b would be minus 17 by 16. That is b. So now we have A and B, and we can replace it here. We would say that this is A plus B squared. A is U, and B is minus 17 by 16 squared. This term that we had here, we will put it still in here because if it was previously, then it has to be now. But if we expand this, like we can see here, there would be a b squared term, which is of the form, this is b squared would be of the form minus 16 squared. That b squared was not originally in the equation, so we have to subtract it, because it will be added when we expand this term. So we have to subtract it. Now we'll do the math. In order to find the roots R1 and R2, we equate this to 0. This will be an auxiliary, so we will change the color. So to take out this root here, it is a square exponent we could send it to the other side as a square root. So this exponent would go to the other side as a square root. And because the square root, inside the square root, it could be positive or negative, we will indicate that with a plus minus sign. So this would be the square root of 961 is 31. And the square root of 256 is 16. U1, 2 are the roots 1 and 2, with this plus 17, 16, which is this other term that we are sending to the other side, changing the sign. So we can check from here what the roots could be. Root 1 would be plus 3116 plus 1716, and root 2 would be minus 3116 plus 1716. That would be the roots. This would be 48, 16, and this would be minus 14 by 16. So root 1, this we could still divide it by 4. It will be 12 by 4. And this will be 3, root 1. And the root 2 would be minus 7 by 8. So these are the two roots. And as we said previously, it will be u minus root 1 times u minus root 2. Root 2 is negative, so it will be plus 7, 8. And this would be the original expression which we had factor. This also can be checked to see whether we did things right or not. In order to check it, we have to distribute it. So we will distribute this u here and here, and then we will distribute the minus 3 also here and here. No, This 3 could be regarded as 24 by 8. So we have a 7 minus 24 would be minus 17. This will be minus 17 by 8u minus 21 by 8. And the last step is to distribute again this 8 here to check if we did things right. And it will be 8u squared minus 17u minus 21, which corresponds to the original equation. So we can say that we checked for the solution. And is there any question? Would you like to ask anything? Okay, we see you next class.